on page 249. If two resistors with resistances R1 and R2 are connected in parallel, as in the figure, there is a figure here. Here they are connected in parallel, R1 and R2. Then the total resistance R is measured in ohms, is given by 1 over R equals 1 over R1 plus 1 over R2. If R1 and R2 are increasing, R1 is increasing at 0.3 ohms per second, and R2 is increasing at 0.2 ohm per second. We're asked to find how fast is R changing when R1, remember this is only at the very end, when R1 equals 80 ohms and R2 equals 100 ohms. So we're given this relationship and we are given some information. We are told that the rate of change of R1 is this, the rate of change of R2 is this. We're asked to find the rate of change of R when this happens. Suggestions. First of all, what are we asked to do? And also, I would like to identify what this means. What do you think this is? Very good. So dr1 over dt. Perfect. What does this represent? Very good. dr2 over dt. What are we asked to find? Very good. dr over dt is what we're asked to find when R1 is and when R2 is, and we should not worry about this just yet. Perfect. Coming back to our relationship, I recommend the following notation, I meant to say. Do you agree? Why do you think I changed the notation of the equation into, instead of 1 over r to r to negative 1, instead of 1 over r1 into r1 to negative 1, and so on and so forth? Why? It's easy to differentiate, of course. Good. So let's do just that. First step. Can anyone help us differentiate this? Yes, negative 1 times R2, negative 2 times, knowing that R, R1, and R2 are functions, dr over dt equals negative 1 times R1 to negative 2 times dr1 over dt plus negative 1 times R2 to negative 2 times dr2 over dt. Of course, I will clean it up by multiplying or dividing both sides by, of course. We have to do that first. Now, if you want, you can change it back into fractions. 1 over r squared dr over dt equals 1 over r1 squared dr1 over dt, and plus 1 over r2 squared dr2 over dt. And then dr over dt, all I have to do is multiply this whole thing by r squared. 1 over r1 squared dr1 over dt plus 1 over r2 squared dr2 over dt. And I'm ready now to plug in R1 80 and R2 100. And I have this as 0.3 and I have this as 0.2. We multiplied everything by negative 1. So the only problem I encounter now is this piece. This is 80. This is 100, of course, squared, both of them. This is 0.3. This is 0.2, but I have to determine that. So I have no choice but go back to the original equation where I replace R1 by 80 and R2 by 100. So 1 over R equals 1 over 80 plus 1 over 100. Why do I need this? It's because I need this piece. Without that piece, I cannot finalize the problem. Let's take a moment and look at this and see if we agree with every step or if you have questions. Any questions, please? Any questions? Okay, how will I solve this equation first? I need the least common denominator. 80 is 8 times 10, 2 to the 4th times 5. 100 is 10 and 10, 2 squared and 5 squared. So the LCD has to have all different factors we see, but I have to choose the highest power. The highest power for 2 is 4. The highest power for 5 is 2. So this will be 16 times 25. Whatever that is. So what do I have? 6 times 25 is 150, right? 150 and 25. So what is that? 2, 2, 6, 5, 0?
Is that 16?
2 to the 4th is 16.
16 times 25 is 1.
Okay. I can't compute anything tonight other than wait for you to calculate for me. Okay, 400, if that's the case, I agree. This needs a 4, and this needs a 5. Excellent. So 5 plus 4 is 9. I flip both sides. I can do that in a proportion. So R equals 400 over 9 ohms. And now we can finally put everything together. So therefore, the R over dt equals 400 over 9 squared, 1 over 6400 times 0.3 plus 1 over 10,000 times 0.2. Careful how you put all this in the graphing calculator. So let's determine this together. So in y equals, no, we don't need that. So it's in parentheses, 400 divided by 9, close the parenthesis and square, open a parenthesis, and we have 0.3 divided by 6400 plus 0.2 divided by 10,000, close the parenthesis, and press enter. I got 0.1321. What does this mean? 0.1321. Measurement unit. And what does it represent? So ohms per second. Rate of change. Excellent. Questions before we select another? Would you like to work on one on your own for a couple of minutes? Yes? Okay. So let's look at 22. A particle moves along the curve y equals 2 sine pi x over 2. As the particle passes through the point 1/3, 1, its x-coordinate increases at a rate of the square root of 10 centimeters per second. How fast is the distance from the particle to the origin changing at this instant? So let's read the problem one more time and make notes. Take some notes on what is given to us and what we're asked to find. So this is problem 22 on 249. We're given the function y equals 2 sine pi x over 2. And we're told that at the point 1/3, 1, the x-coordinate increases at a rate of the square root of 10 centimeters per second. And now you'll tell me what this represents. How fast is the distance from the particle to the origin changing at this instant? So if you want to graph the sine function, I hope you remember the sine function is something like this. One-third, 1, it's somewhere here. First of all, what is this? We're reading the problem one more time. A particle moves along the curve. As the particle passes through this point, its x-coordinate increases at a rate of the square root of 10 centimeters per second. What does this represent? Dx over dt. Perfect. How fast is the distance from the particle to the origin? So what are we asked? Let's call that W. So what are we asked to find? We're asked to find dW over dt when x is 1/3. So we cannot use it just yet. Of course, don't cross it out like that. I'm just making a point, trying to make sure you understand that the when cannot come into play before we find the function and its derivative. And then we can plug in numbers. So let's think for a moment. So you cannot connect these two. You have to say the particle is anywhere. This is the W. And here's my hint. So we're asked to find dW over dt. And I know that this point has two coordinates. One that is this and one that is this. What is this coordinate? What do you want to call it? You can only call it x. It's on the x-axis. It's the x-coordinate of this point. Okay, what is this then? Right, but now I have to put what y equals to. 2 sine pi x over 2. So now let's think for a minute. What do you think we'll have to write? Of course, you will say w squared what? Equals? Very good. Plus? Exactly. 4 sine squared pi over x, pi x over 2. Awesome. Then what?
Oh, we can 4.
We have to square,
Oh, so
right? Right? The Pythagorean theorem. Now what? And we have to remember that x is the variable or a function of time. X is a function of time. It's already given to us. We know that from here, that x is a function of time. Okay, so can anyone tell us anything, or you want to think about it for a minute?
question. So is dx over dt the square root of 10?
Yes. Centimeters per second. Yes.
You differentiate.
Correct. Very good. So the left-hand side is 2w dw over dt. Awesome. The right-hand side, 2x dx over dt. Now very careful. Eight. Very good. Sine pi x over 2. Awesome. Times, indeed, times cosine pi x over 2 and times, exactly, very good, exactly. I have to differentiate pi x over 2, so it's pi over 2. You need me to do this again, yes? Please say yes if you need me to do this again. So one more time. We brought the power down and we multiplied by 4 and we got 8. We subtracted 1 from the power and we got sine pi x over 2. Now I'm here and I have to differentiate sine. So I have cosine pi x over 2. But now I'm finally here and I have to differentiate this and I get pi over 2. Agreed? Every step? Okay, perfect. So then, of course, I will divide both sides by 2. So we have w dw over dt equals x dx over dt plus, this is divided by 2, so I have 4, but I also am going to divide by this, so I have plus 2 sine pi, 2 pi, I'm going to put pi next to it, pi x over 2 cosine pi x over 2. Times dx over dt. So when I differentiate pi x over 2, it is pi over 2, but x is a function of time, so I need dx over dt. So of course, times dx over dt. And now I can solve for this when x is 1/3. And let's see what we have, and let's see what we don't have, and what we need to determine. Because it's not all in there. I don't see it. So dw over dt. So x dx over dt plus 2 pi sine pi x over 2 cosine pi x over 2 dx over dt. So let's see what we have and what we don't. X is 1/3. So this is 1/3, and this is the square root of 10. And this is the square root of 10. This, from here, I have to take the square root from both sides to get the w. So the square root of x squared plus 4 sine squared pi x over 2.
So did you divide cosine pi x?
No, I cannot separate these two. And I cannot separate these two. So I had an 8. I divided by 2 because I divided everything by 2. So it became 4. But then I divided by 2 and it became 2. So I have the pi in front. So I'd rather go back and check. That's fine. So then I copied this and I copied this and then dx over dt. Is that okay? I'm not sure, did I answer your question or not?
Yeah.
Yes? Okay. So this is 1/3, this is the square root of 10, the square root of 10. This is 2 pi, there's nothing I can do about it. This, when x is 1/3, this will be sine pi over 6. And when x is 1/3, this will be cosine pi over 6. And this will be 1/3 squared. And this will be pi over 6. We have to clean it up. I'm not going to put it as is in the graphing calculator. I have to rearrange everything. So this is when x equals 1/3. So dw over dt when x is 1/3 is 1/3 times the square root of 10 plus 2 pi the square root of 10 times sine pi over 6. Do we remember sine pi over 6? Is 1/2. Smallest angle, sine pi over 6. Cosine pi over 6, however, is the square root of 3 over 2. Now over the square root of 1 over 9 and plus 4. Sine pi over 6 is 1/2, but it has to be squared times 1/4. So now I can put everything in the graphing calculator. But before we do that, please let me know if you have questions. Any questions? Are we okay? So I replaced x by 1/3. I replaced this by the square root of 10, and then 2 pi. I put the square root of 10 here. I determined that this is 1/2. I calculate that this is the square root of 3 over 2. Then this will be 1/9. There is a 4. And sine pi over 6 is 1/2, but I have to square it because the power. And this will be 1, of course. So now in the graphing calculator, careful how you put it in, because you need enough parentheses around the top. So left parenthesis, the square root of 10, close the parenthesis. You may not need parentheses, but you know me already, divided by 3. And then plus 2 pi, the square root of 10, um, 0.5 times 0.5. Let me put multiplication symbol. I don't know if it's going to make a difference or not. Multiplied by the square root of 3 over 2. Close the parenthesis for the top, and divide by square root in parentheses 1 divided by 9 plus 1. Close the parenthesis. And let's see what we get. I got 9.16. Measurement unit. $9.16. Did anyone else get 9.16? Careful. It's not an easy situation with all those numbers in there. Any questions? It means nothing if it does not have a measurement unit. What is the measurement unit? Centimeters per second. Very good. It's a distance. Excellent. Questions? One more easy one and we'll stop. So let's take a look. 97 on page 267. 97, 267. The volume of a cube is increasing at a rate of 10 cubic centimeters per minute. How fast is the surface area increasing when the length, everything that follows after when, you know you cannot put it in till the last second, when the length of an edge is 30. So the volume of a cube is increasing at a rate of 10 cubic centimeters per minute. So this is problem 97. One more time on 267. So what is given to us? We are told, what are we told again? That the volume of a cube is increasing at 10 centimeters cubed per second. What does this mean? Of course, dV over dt. Awesome. How fast is the surface area increasing? So what am I asked to find? When x, the edge, is 30. Remember, this cannot be put into play just yet. We're asked to find how fast is the surface area increasing when the length of the edge is 30. Okay. Here is the cube. So what is this? ds over dt. So we're asked, yes, we're going to write it in a minute, but the question is asking us to find how fast is the surface area changing, increasing in this case, when one edge, which is all of them, right, when the edge is 30. Okay, so now we start with, so now we can write both formulas. Can anyone give us the volume of a cube and then the surface area of a cube? And the edge is x. Very good. This is indeed x cubed. Good. And the surface area of a cube. How many sides? 6. And what is the area of one side? That's it. Perfect. So we are given dV over dt. Let's start right there. Or let's start here. So when I differentiate the left-hand side and the right-hand side, what do I get? I do get ds over dt equals 12x times dx over dt. So there is not going to be a problem to plug in 30 here. This is a number, but this I don't have. I have to get it somehow. But I haven't used all the information that was given to me yet. I'm clearly stating this. I'm clearly given this. I have to use it. So then I should differentiate both sides. And I get dV over dt equals 3x squared times, right. And all the information is given to us from here to determine dx over dt. I divide both sides by 3x squared. So dx over dt equals dV over dt, everything over 3x squared. And this will replace dx over dt that I don't have. So what do I write?
something?
Yes. So I have ds over dt, 1x equals 30, but I cannot put it in just yet. 12x, and instead of this, I copy that. So dv over dt, everything over 3x squared. Of course, I'll simplify by 3, and I'll take care of 1x from there. So this is then 4 dv over dt, everything divided by x. This 1x is gone. There is an x in the denominator, and 3 and 12. So then I have 4 times 10 divided by 30. So this is 4/3. Not sufficient without a measurement unit. So what is the measurement unit? Depends on what I'm determining. And I'm determining what? Yes, it must be centimeters squared per second. The rate of change of surface area with respect to time. Say it again. Oh, was it minutes? I'm sorry. Sorry. Was it minutes? I wrote 10 centimeters cubed per second. Is it, maybe you're right. Let me look. I'd rather go back and check. Was it seconds? Yeah. Okay. Question.